Hello friends of EduMath, my name is Makumba Gerard. In this video, we are going to look at drawing the frequency distribution table and the measures of central tendency for data with no decimal places. And if you are new here at EduMath, please consider subscribing and hitting that notification bell such that you are notified of our new uploads. For now, let's get started with an example. The table below shows marks obtained by 25 students in Senior 5 in a mathematics test marked out of 35. These are the results. Then they need us to draw the frequency distribution table for the marks, starting with a class of 10 to 14. This is a class, but they are not class boundaries. Then they need us to use the table above to find the three measures of central tendency. First, we consider our class, which is 10 to 14. Now, the data which we have is the data of no decimal place. So we have to go ahead to find the class boundaries. Class boundaries will help us to find the class width. So from the tolerance error, this is going to be equal to half times 10 power negative n. For this time around, n is equal to 0 because n stands in for the number of decimal places. So the tolerance error that we have at the moment, it is going to be equal to 0.5. When you put here n as a 0, we shall remain with a half, which is 0.5. Now, we need to go ahead and then get the class boundaries using this class here. So class boundaries. So if we are to find the class boundaries of this class, from our previous video about class boundaries, we say we shall be taking away 0.5 from the lower limit and then adding 0.5, this tolerance error here, on the upper limit. So the class boundaries will be 9.5 to 14.5. This being the lower class boundary and this being the upper class boundary. Then the class width, capital C, which is the same as the class size, which is the same as the class interval, we denote it with capital C. This is equal to the upper class boundary minus the lower class boundary. So the upper class boundary, this is 14.5 minus 9.5. C is going to be equal to 5. Now we are going to use the class width together with this first class to generate all the other classes. And after that, we shall do the tallying, which helps us to come up with the frequency. So now, since these are marks, we are going to have here the marks, and then we shall have tallies now that our data is still ungrouped. Now, let us start putting in the classes. We have the smallest class they need us to start with is a class of 10, 14. Now to get the next classes, we shall make use of the class width. So our class width is 5. What we are going to do is to keep on adding 5 on the lower class limit, 5 on the upper class limit. Having it in mind that we shouldn't go beyond 35 because we know that our values here do not go beyond 35. The test was marked out of 35. So plus 5, which is our class width, you get here 15 plus 5 is 19. The next class, we shall also do the same thing. We shall keep on adding our class width. So 15 plus a 5, here we shall have a 22. 19 plus a 5, this will be 24. Plus 5, 25, 2, plus 5, 29, plus 5, this is going to be 30, plus 5, we get here 34. Now we go back to our table and we check on the raw data that has been given to us. You can see that there is no value which goes beyond 34. In fact, the maximum value should be 35 because this test was marked out of 35. Next, we are going to do the tallies. So how do we do the tallies? We do not read one value at a go. So there is a skill that we are going to again learn. So we have 12. 12 is a value that lies between 10 and 14. So we put here our tally. 15 lies here. We have 23 lies in here. 26 is a value that lies in here. 21 is a value that is belonging to that class. 32 belongs here. We have 25 belongs there. 33 belongs here. 20 is a value that belongs in that class. 21 belongs in this class here. 28 belongs there. 24, we make a band of 5 here. 25 we have there. 26, we make a band of 5 there. 18 is a value that belongs in that class. 34 is there. We have 30 is a value that is here. 31 also makes a bundle here. We have 27 belongs here. 29 is a value that belongs here. 27 belongs here. 16 belongs in here. 19 there. We have 20 belongs here. Then 14 is a value that lies there. So having come up with the tallies, we are now going to create a column of frequency. So we put here smaller f, which denotes the frequency, and then we just start counting the tallies. So we have here 2, have here 4, these are 6, these are 8, these are 5. So if we happen to add all of them, that means we are getting summation f. So summation f, this should add up to 25. Because they told us that there are 25 students in near 5. So we can just confirm that, yeah, this is 6, 12, 20, 25. We can see that. Next now, this here which we have is the frequency distribution cutting off from here. These 3 columns which we have is the frequency distribution table. We have distributed our raw data in 2 classes. Now, the next thing which you have to observe is that these classes are arranged in order from the smallest to the biggest. Now, this enables us to get the median, because to get the median, your data should be arranged in ascending or descending order. Alright, now we need to calculate the mean. We need to calculate the mode, which depends on the frequency. So right now we can be able to calculate the mode. Then we need the median, which depends on the cumulative frequency. So within our table, we are going to add in columns of x, column of fx here. We shall have a column of cumulative frequency, and then we shall have a column of class boundaries. Now we start by getting the values and the column of x. X is the mid mark. So mid mark is got by getting the average of the extreme points of the class. So you get 10 plus 14 divided by 2 for this first class, and this will give us a 12 here. 10 plus 14 divided by 2 is 24 all over 2, which is this 12 here. Now, to get the rest of the values here, you can do the same mathematics, average, taking the average. But now, since that we have our data being of uniform class width, right, as being 5, what we are going to do here is we are just going to keep on adding the class width. Keep on adding the class width. So for example, 12 plus the class width, which is 5, this is going to be 17, plus 5, this will be 22, plus 5, this will be 27, plus 5, this is going to be 32. So this is to help us save on the time, but it is only done if the data has equal class width. Next, we need to get fx. F is here and x is here, so we need to keep on multiplying them. So 2 times 12, this is going to be 24. 4 times 17, 68. 6 times 22, we get 132 here. 8 times 27, we are getting 216. 5 times 32, 160. Then we get summation fx, which is equal to, when we add all of this, we get 600. The next thing is to get the cumulative frequency, which helps us in finding the median. So we transfer it to here, then the rest of the values we keep on accumulating or keep on adding. So 2 plus 4, we get here a 6. 6 plus 6, we get here a 12. 12 plus 8, we are getting a 20. 20 plus 5, we get 25. Right? Now, The column which is remaining is for class boundaries, and already we have the tolerance error at 0.5. So we are going to take away from the lower class limit the tolerance error, which is 0.5, and we shall add the tolerance error on the upper class limit. So take away 0.5, this is 9.5 to 14.5. Okay, so the other classes you can as well still keep on adding the 5. Now, why are we creating the class boundary? Class boundaries come in to make our data continuous, because grouped data should be continuous. So minus 0.5, we get here 14.5 to 19.5, 19.5 to 24.5, 24.5 to 29.5, 29.5 to 34.5. So those are our class boundaries. Next, now that we are done with our table and coming up with the necessary columns that we can be able to use to find these three measures of central tendency, so we begin with finding the mean. X bar, this we say it is summation fx divided by summation f. But what is summation fx? This is 600 divided by 25. So mean x bar is equal to 24. Mod is equal to L1 plus, this is D1 over D1 plus D2. Everything we multiply it with the class width. Now, we know that mod is a value which appears more often, or the value with the highest frequency. Now, for the case of grouped data, it's not obvious, so we have to find it, okay? But this time, we have to know that the mod again should be coming from the model class. So we are going to first identify the model class as the class with the highest frequency. So the model class is this here, 25 to 29, because it has the highest frequency as 8. So from there, we can go ahead and have mod being equal to the lower class boundary is 24.5 plus, we need to get D1, the model frequency minus frequency before, so this is 2 divided by 2 plus D2 is model frequency minus frequency after, so this is a 3 here, then times the class width, which is 5. So this is 24.5 plus this is 2 times 5 all over 5. So mod becomes 26.5. That is our mod value. The third parameter they need us to find is the median, which is equal to L1 plus N all over 2 minus cumulative frequency before all over the frequency of the median class times the class width. Now, to find the median, we first get the median position. This is got from this point here, N over 2, but it is a position, so it should have this here value. So this is going to be 25 all over 2. So median becomes 12.5. So the median position, this value here. So where do we read the median position from? The median position is read from the cumulative frequency. So from here we now have the median being equal to, let's first read the 12.5. This is the cumulative frequency. 12.5 can't lie here. So 12.5 is a value that is inside here. Right? So our median class is a class of 25 to 29. So from here we go ahead and get the lower class boundary, which is 24.5 plus N over 2 is just 12.5 minus the cumulative frequency before is 12 divided by the frequency of the median class. Frequency of the median class is 8. Then everything here times the class width, which is 5. So median is equal to 24.813 and this is the 3 decimal places if you compute on your calculator. So my dear viewer, in case of any clarity, you can always play back the videos, and if you are new here at EduMath, please consider subscribing and hitting that notification bell. Now my dear viewer, before we go, I would like to leave you with one number that you are going to try out on your own. If you get it, then you can go ahead to get more other questions for trying. So we've got our tryout question here. You can pause the video and have it written down, then you try it out. There we shall be gaining a lot. For now, from us EduMath, we would like to thank you so much for being part of our community. And right now, we would like to wish you the best. See you in the next video.